Hello everyone, welcome back to Nisha Academy video lecture. In today's maths video lecture, we would start with our new chapter, Understanding Quadrilateral. This is our third chapter and it is also a very important chapter. In today's video lecture, we would be covering the following topics. First is Introduction to Plane Figures, polygons, classification of polygons, diagonals, concave and convex polygon, regular and irregular polygons, and exercise 3.1 that would be we will be completing half because it is a very big long exercise. So starting with our chapter, firstly we will do introduction to plane figures. Now what are plane figures? Figures which we can draw on a paper with the help of pen, pencil or any drawing tool. We can draw it on a paper is called a plane figure. Now in plane figure there is a plane curve. What do you mean by now plane curve? When you join a number of points without lifting a pencil from the paper and without retracting any portion of the drawing except single point is called a plane curve. By suppose here this is circle, we'll start from here and we continue to do this. This is what is a plane curve. Like here we'll start from a point and we'll end here. This is a plane curve. Without lifting our pencil, we would draw it from a single point is called a plane curve. Now, plane curve are of various types. These are simple curve, closed curve. What do you mean by simple curve? Curves that do not intersect themselves are called simple curves. Means the starting and ending point does not intersect. Here this is one type of Z, but its starting and ending point does not meet. The same way in this spiral also, starting point is here and ending point is here. This is called a simple curve. Next is closed curve. Closed curve means it does not have any end point. Its starting point and ending point are same and it encloses a closed area. That is called a closed curve. See here a star. I would start from here and draw like this. So I would start from here and end here. So it is called a closed curve and you can find the area of this enclosed by this star. The internal part is called the area enclosed by the star. This is called a closed curve. Next is open curve. Open curve means it does not encloses an area. It is not a closed figure and its starting and ending points are not same. See here you can see it is open from this part. If you can see it is open from this part. So we can say that it is a open curve. So there are three curves: simple, closed and open. Simple curve means it is just simply starting and ending point are not same, but it is a simple curve. Curves that do not intersect themselves, they don't intersect each other. Any point does not meet with each other. Closed curve encloses a closed area and its starting and ending points are same. Same way in open curve, starting and ending points are not same and does not enclose any area, but it can intersect each other. Like these two lines are intersecting each other at this point. Our next and most important point is polygons, on which the whole chapter you are going to study. Polygons means what? A simple closed curve made up of line segment is called a polygon. You need to remember that it is a simple closed curve. Closed curve means the figure encloses an area and it is made up of a line segment. Now you can see here the example triangle and rectangle. Triangle, it is made with three line segment and it encloses an area. Same way rectangle too. But here you can see that here it is not a closed figure. Here also it is not a closed figure, it is open from here. So this two cannot be said as a polygon. These two are examples of polygon. Now there are various types of polygons on the basis of number of sides. I have here classified number of sides, like number of side 3, then the name is triangle. 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon, 8 side octagon, 9 sides nonagon, and 10 sides decagon. See, you have to remember this name because you will be asked to like question like write the area, find the angle sum property of heptagon. So you should know it has how many sides. Heptagon has 7 sides. So you need to remember this. Our next topic is diagonals. See, you have studied about diagonals. In previous classes, you would have heard about diagonals of but in this you will study it in a deep. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Non-consecutive means they are not coming next to each other. Like in this figure, it is a rectangle. Here C and B. Here consecutive vertices are which one? A, C, A, B, B, C and C, D. While non-consecutive means which are opposite to each other, like A and D, B and C. When you join this opposite vertices, you get a diagonal. Like by joining AD and BC, you get a diagonals of a rectangle. So what do you mean by diagonal? Diagonal means line segment which connects two opposite vertices or two non-consecutive vertices. Whichever word you find simple. You can write two opposite vertices also. Same way, this is a hexagon. Hexagon, why? Because it has 6 sides. 1, 2, 3, 4, 5, 6. Now when you join the opposite vertices, see, opposite vertex of A is D, B is E and C is F. When you join this opposite vertices, you get diagonals of a hexagon. In figure 1, AD and BC are diagonals of rectangle ABCD. And in figure 2, AD, BE and CF are the diagonals of hexagon ABCDEF. Continuing with our lecture. Next topic is convex and concave polygon. Now what do you mean by convex and this classification of polygon is on the basis of diagonals. That first is convex polygon. What do you mean by convex polygon? In convex polygons, the diagonals are in the interior part of the, means inside part of the polygon. Polygons in which each and every diagonal lies entirely in the interior of the polygon are called convex polygon. Means the diagonals are the part of the polygon. They lie inside the polygon. Now in this rhombus, see, both the diagonals are in the inner part. Which are the diagonals? These red lines are the diagonals and are in the internal part. Same way for this trapezium also, they are in the internal part. While in concave polygon, it is exactly the opposite. All the diagonals are not in the interior part of the polygon. Means they does not lie in the inner part of the polygon. Like in this figure you can see that one diagonal, the opposite vertices are there, one diagonal is inside but the other diagonal is outside the polygon in the external part. Same way in this also, these two diagonals are in internal part while this one is in external part. So these are called concave polygon. What is the difference in convex and concave? In concave, all the diagonals are in an internal part of polygon, while in concave, one or more are outside the polygon. Our next topic, for today's lecture is regular and irregular polygon. Now what do you mean by regular and irregular? The regular word you can itself say the regular means all its sides and angles are equal. In regular and irregular polygon, the simple difference is that in regular polygon, all its sides and angles, interior angles are equal. For example, equilateral triangle, all its sides are equal and all its angles are 60 degree. While in square also, all its sides are equal and all its angles are 90 degree. But in irregular polygon, it is not necessary that all sides and interior angles are equal. Any two sides can be equal. Any one pair of two sides can be equal. Angles or any angle can be equal. When this is the condition, they are called irregular polygon. Here I have given an example. First is rectangle and other is a right angle triangle. So up till now we have studied plane figures, its type, simple curve, closed curve, open curve, then diagonals, concave and convex polygon, regular and irregular polygon. Now related to this is an exercise number 3.1. Starting with our exercise 3.1. First one is you have been given the figures. Given here are some figures. Here are some figures and you have to classify them into simple curve, simple closed curve, polygon, convex polygon and concave polygon. Now what do you mean by simple curve? That the points do not intersect each, they don't meet, are a simply drawn, simple drawn figure are called a simple curve. Like you can see in first one, first is there, second is there. Third is not a simple curve because it is both figures are different and it does not have any side. It is a circular region. Curve means it should be formed with a line segment. Like same way here also there in fifth there is curve but they are meeting somewhere or the other. So in simple curve means you can have simple curve we can say, but it should meet somewhere. It should meet each other. In circle here you don't have any meeting. Here if you see in this star, it both all the points are different. All points are not mixing with each other. Here there is a circular region but it meets somewhere at a point. In this sixth also it meets. In third one the two circles are not meeting each other. In seventh one you can see whole part is somewhere or the other intersecting each other. And in this figure both are different. So we can say that which is a simple curve 1, 2, 5, 6, 7. Same way simple closed curve. Closed curve means it encloses an area. Like first, second, you can say third, fifth, sixth and seventh. Fourth is also a simple closed curve. Same way you have to answer which one is the polygon, convex polygon and concave polygon. I have already given you the meaning. You can try it by your own. Going to our second example. Second question is how many diagonals does each of the following have? You have been asked 3. A convex quadrilateral, a regular hexagon and a triangle. Now to know how many diagonals are there, you need to draw the figure. Now convex quadrilateral. Quadrilateral means having 4 sides. Draw a quadrilateral and join the opposite points. Here you can see in the figure, I have drawn a quadrilateral. Here it is having a quadrilateral and I have oppositely joined. So how many diagonals it have? 2. The same way in regular hexagon. Hexagon means having 6 sides. So joining all the opposite vertices you would get 9 diagonals. And in a triangle, third, triangle does not have any diagonal because its opposite vertices are already joined. So a triangle has no diagonal. Now third one. What is the sum of the measures of the angles of convex quadrilateral? Will this property hold if the quadrilateral is not convex? Now to find the angle sum property of a polygon, it has a formula. Number of sides minus 2 multiply by 180. This is the formula and you have to learn it by heart. Which is the formula? Number of sides minus 2 multiply by 180. So quadrilateral, we know quadrilateral has 4 sides. So the angle sum property of a convex quadrilateral is 4 minus 2 multiply by 180. 4 minus 2 gives you 2. So 2 into 180 will give you 360. See, any quadrilateral you take, whether it is a convex or a concave, the angle sum property is 360 degree.